We're given to express the following in rectangular format using the DeMoivre's theorem. We have given A, the number 1, our z is equals to 6 into negative 30 degrees multiplied by 4 angle of 90 degrees. This all over 3 multiplied by 10 there. All these raised to the power of 3. So our z will be equals to, let's multiply the coefficients there, 6 multiplied by 4, our r there, let us multiply that, then we'll be left with, after we've multiplied this, now we have to add the angle. We'll make one thing, we add the angle, you'll add 30 and 90 minus 30 plus 90, divide this into 3 into 10 degrees. Now z will be equal, multiply this 6 multiplied by 20 by 4, which is 24, negative 10 plus that will be 50. We'll have obtained, or we'll obtain 60. Negative 30 plus 90 will be 60 degrees. Divide this by 3 to angle of 10 degrees. So the answer there, we have to divide these two. 24 divided by 3 will obtain 8. Then 60. These two we have to subtract 60 minus 10 according to the rules of Moivre's theorem. Then this will be 8 into 50. We'll obtain our 50 there. 50 degrees. So we have to express this in the rectangle. We know this is simply equals to r theta, like that. This is what we have. This is what we suppose. This is what we have, actual fact. So we have this, our result there, modulus. This is our argument. So we can express that. We know that to rectangular format, we can say the rectangular format can be given by a plus b I, like that. We know we want it to be expressed like this, or we can use j. Some of the textbook use j, it's one and the same thing. Some I is equals to j. Some of the textbook they use j like this. So we have to express this in the rectangular part. We know to express that from the polar form going to rectangular format, we have to use this formula that says we have r, the modulus must be multiplied by cos, the cos of what, cosine theta, or the argument, minus plus b. Yeah, we can use b, the imaginary path. Yeah, we can use b as an imaginary path, or in, yeah, we can use b. Let me just say I, or it's up to you, b, I, like that. It's what we're supposed to use. So we'll have, let me just say is this guy there, but I will just say I multiplied by sine theta, like this. All right, this correspond with that part. This is a real part, this is an imaginary part. So we have our r here will be 8, the angle is 50. So That is what is that we have. So let's check. There's something we have forgotten here. Remember, okay, this was raised to the power of 3. How can I forget that? This must be raised to the power of what? Of 3. All these must be raised to the power of 3. Alright, so that means also this must be raised to the power of 3. So that means since this is raised to the power of 3, we have that 50 like this, raised to the power of 3. Then we'll have 8. We'll raise 3. We'll have 50. Then we multiply the angle by 3. So this is what you're supposed to do. That means here we'll have 8 raised to the power of 3 will be 512 into 50 multiplied by that, it's 150 degrees. So this is what we have. Sorry guys about that thing today, I'm just tired, but anyways it's this. So that means our R will be 512. The cos theta, the argument will be 150 degrees plus I sine 150 degrees, like that. So the rest is history. You just use your calculator. 512 punching, we substitute. Where is this theta now? Why I'm putting theta here? 150 plus that, you punch 150, obtain negative 0.866 plus sine 150 will be 0.5. So multiply that, distribute, we have negative 443,392 plus I 256. So this is our rectangular format. This is what the real part, this is an imaginary part there. So that is it. We're given now number 2 there. We're given number 2. Given 2 z is equals to 3 into cos pi over 3 plus I, or let me use j because they've used j here. Let me just say j sine pi over 3. All these must be raised to the power of 2. Alright, so I have z is equals to, we apply Moivre's theorem. Let me first, don't like to work with rats, let me work with the degrees. I'll just rewrite this as 3 cos pi over 3 is same as 180 divided by 3 will be 60 degrees plus j sine 60 degrees. Alright, all of these raised to the power of 2. So what we'll have now, use Moivre's theorem, we'll have 3 raised to the, we'll raise it to the 2th, isn't it? We'll raise that, must be, we have cos 60, but remember you have to multiply the angle by the power there by 2. So we'll multiply this by 2. Our argument will multiply by 2 plus j sine, there we have 60 multiplied by 2. So this is what we'll have there so far. how cool is this? Then here this is simply 9. So what about that? It's 120. We have cos 120 degrees plus I'm used to, okay, j sine 120 all right. So I have 9 cos 120 is negative 0.5. All right, negative 0.5 plus j sine 120. We have some decimals there, 866. So I'll multiply that. I'll have minus 4.5 plus, when I multiply this, I'll have j 0 comma okay, multiply that will be 7,794. So this is a rectangle format. So this is what it's a, this is the imaginary part. So that is it in this video. This is how you go about. Thank you for watching.